In this video, we're going to have a guided walkthrough through several balanced reaction practice problems. So go ahead and pause, give these three a try, and then come on back and we'll solve them together. All right, if you're back, well, first thing first, let's go up here. Iron 3 bromide plus sulfuric acid makes iron 3 sulfate and hydrobromic acid. So I'm going to pick iron. I've got iron on only one molecule on both sides, but one of them has 2 and one of them has 1. So I'll set the Fe2SO4 3 to 1. That gives me 2 irons, which means I must have 2 iron 3 bromides. That's the only way to get 2 irons. I need 2 of that entire molecule because I cannot change the formula. So all I can do is have multiple of the molecule to get those irons. As a result, though, well, this now means I have several of the other components. I could pick either one. Let's do bromine. As a result of setting the iron, I now have 6 bromines over on the left. This means I need 6 bromines on the right, and the only way to do that is to have 6 HBr. Well, if I have 6 HBr, that means I have 6 hydrogens, and the only source for them is from H2SO4. If I had 3 H2SO4s, that would give me 3 times 2 hydrogens for 6 hydrogens. It also gives me 3 sulfates, which, if we think back to our starting iron 3 sulfate, well, 1 times 3, I had 3 sulfates. So this works out. It is 2 iron 3 bromides for every plus 3 sulfuric acids will give me 1 iron 3 sulfate and 6 hydrobromic acids. Number 2, we have lead nitrate, specifically lead 2 nitrate. We have sodium iodide, becomes lead 2 iodide, and sodium nitrate. Well, first thing first, I've got lead on both sides and only one thing. So we'll set one of them to 1, which means I need a single lead on my product side, so I need a single lead 2 iodide. The result is this gives me 2 iodide, and the only way to have that from sodium iodide is to have 2 sodium iodide. This then sets my I the same on both sides. My iodide is 2 and 2. As a consequence, though, this gives me 2 sodiums over on the left. And so I need to balance my sodium nitrate to have 2 sodiums on the right. Consequence, this means I now have 2 nitrates, which way back at the beginning was the other counterion, and would have had 2. And so this has successfully balanced all the ions. It is 1 lead 2 nitrate for every 2 sodium iodide. They produce 1 lead 2 iodide and 2 sodium nitrates. Our final molecule is deceptively simpler. I have NO plus O2 makes NO2. At first, I would look and say, well, 1 and 1. That's great. My nitrogens are 1 on each side. This, however, leaves me with 2 oxygens on my right and 3 on my left. Well, the only way to kind of balance that out I can't change my NO, so I need a half O2. Well, you can't have a half O2, so really this becomes 2 NO plus O2 goes to 2 NO2s. So effectively this was an NO, there was an O2, another NO, and each of them stole one of those oxygens. And so this is one where we needed to multiply in order to be able to balance this reaction properly. All right, I hope you enjoyed those practice.